Have you ever wondered if you have to pump the sea water dry when building the piers of a bridge across the sea? The answer is definitely no. First, a few trained divers are needed, and then a temporary approach bridge is built to reach the location of the piers. The diver's task is to dive underwater and use explosives to blast away the fragile surface of the seabed. A drill is first used to hit the seabed to the necessary depth, which allows the blast to be optimized. The diver then aligns a blast pipe with the opening of the hole, which is used to place the bomb. Once the bomb has been lowered, the raised portion of the seabed can be safely and effectively blown away until a relatively solid seabed emerges. Once all is blown flat, the loose surface of the seabed is further cleaned using a high-pressure hose, and finally the knocked-down rocks are cleared from the surface by a crane. A steel-reinforced, wood-paneled structure is now constructed on this surface, the frame being a prefabrication of cubes, which is assembled on the seabed by workmen. It takes about 6 months to complete the assembly of the steel structure, and after 6 months, the surface of the steel structure is covered with a waterproofing sheet, and up to this point the concrete grouting machine is ready to go in. The grouting machine fills the whole steel structure wall with cement from this opening downwards. If the concrete is grouted directly in this way, it is easy to be mixed in seawater and cannot solidify properly, so it is necessary to use a special proportion of cement. Then connected to the seabed by segmental pipes, the concrete is poured in from above and deposited at the bottom of the steel structure, and then piled up layer by layer until it fills the entire wall of the abutment. When the concrete is completely solidified, then the seawater inside will be drained. The geology at the bottom of the abutment is still relatively soft, and it needs to be sunk 15 meters before it reaches a strong enough rock layer. But this wall is not strong enough for the time being, because the pressure of the seawater combined with the huge ocean currents makes this temporary concrete wall very unsafe. The first step was to install blasting machines, transportation pipes, worker shafts, ventilation ducts, etc. Next, a thick reinforced concrete slab was poured at the bottom of the site, and underneath the slab was the construction area, which was accessed by workers and technicians through this worker shaft. Workers and technicians enter the construction area through this worker's shaft. Workers are constantly digging out rocks and soil, and the construction process is carried out with the aid of various monitoring equipment. Injecting compressed air from this tube into the inside prevents water seepage by making the pressure in the construction space greater than the water pressure. The bottom of the wall is in the shape of a cutter, and during the excavation process, the entire wall of the abutment sinks slowly, guided by the bottom of the cutter, until it is dug down to a sufficiently hard rock layer. At this point the ground is made level, filled again with steel, carried away with its belongings, and then the pouring of concrete into it begins. Up to this point, the main body of the abutment has been built, and you can begin to erect the tower on top of it. Before erecting the tower, the surface of the concrete abutment needs to be sanded and smoothed, and then a thick steel plate is laid on the foundation. Erection of the tower are finished prefabricated parts of the mechanized assembly, until the final roof of the entire process is not complicated. The only need to overcome this fearful construction height. This is the construction process of the piers of the Golden Gate Bridge more than 90 years ago, and it has many pioneering techniques that have become models of modern bridge construction and are still being studied and used today.